Let's be real, you're probably watching this on some kind of digital device right now. But have you ever stopped to think about what's actually happening inside that little machine? Well, in this explainer, we're going to pull back the curtain on the tech you use every single day, and we're starting with the one that's probably in your hand right now, your smartphone. So let's get right to it. What really makes that device in your pocket smart? I'll give you a hint, it's not just one thing. It's actually a whole team of hardware and software working together perfectly. So how about we meet the team? We're about to go on a little journey inside your phone. Metaphorically, of course. And the cool thing is, once you understand the basic parts of your phone, you'll suddenly realize that these same ideas apply to pretty much every digital device out there, from your laptop to your gaming console. Okay, first up, let's meet the two most important players on the team, the brain of the device and its memory. Or a better way to think of it might be its workspace. Meet the CPU, the Central Processing Unit. This thing is the absolute brain of the whole operation. Every single time you tap, swipe, or launch an app, the CPU is the part that's actually processing that command. It's like the head chef in a super busy kitchen, instantly taking your order and telling all the other parts what to do to get it done. So how do we measure how powerful this brain is? We use something called gigahertz. And really, all you need to know is that a higher gigahertz number means a faster, snappier experience for you. You know that awesome feeling when an app opens instantly? Yep, that's a high gigahertz number doing its thing. Next up is RAM, which stands for Random Access Memory. The absolute best way to think about RAM is like a workbench. It's where your device keeps all the stuff for the apps you have open right now. The more RAM you have, the bigger your workbench, and the more apps you can juggle at once without everything slowing to a crawl. But, and this is key, it's temporary. Turn the power off, and that workbench gets wiped completely clean. And then you've got ROM, or read-only memory. Now, if RAM is that temporary workbench, think of ROM as the permanent instruction manual that's literally bolted to the wall. It holds the super basic, essential instructions your phone needs just to wake up. It's the device's survival guide. So let's just nail this down. RAM is your active, temporary workbench that lets you multitask. ROM is the permanent, unchangeable instruction manual for just starting up. One is for doing, the other is for booting. It's a simple difference, but it's absolutely crucial. Okay, so we've got the brain and the memory. But all that hardware, well, it's just a fancy paperweight without instructions, right? That's where the software comes in. You can think of it as the digital soul that actually tells the machine what to do. Software really comes in two main flavors. First, you have the system software. Think iOS or Android. This is the manager of the whole device. Then you have application software. That's just a fancy name for your apps. Those are the tools you actually use to do stuff like send a text, play a game, or edit a video. So let's see how this all works together when you just turn on your phone. First, you hit the power button. Immediately, the ROM kicks in with those startup instructions. That tells the device to find the main operating system in storage and load it onto the RAM workbench. And once that's done, boom, your home screen appears and you're ready to go. The operating system, or OS, is really the unsung hero here. It's the master manager doing 1,000 things in the background. It's what lets you run multiple apps without everything crashing. It manages your battery to keep things efficient, it handles security, and it creates the entire user interface you actually see and touch. It's the ultimate multitasker. All right, so we've got the brain, the memory, and the software soul. But how does our device actually interact with us and with the world? Well, it does it through its senses and its long-term memory, or what we call peripherals and storage. Input devices are pretty straightforward. They're how we give the device commands. On a smartphone, your main inputs are the touchscreen, the microphone, and the cameras. On a desktop computer, it's the classic keyboard and mouse. Basically, they're the eyes, ears, and fingertips of the machine. And if input devices are how we talk to our tech, then you guessed it, output devices are how it talks back to us. The most obvious one is the screen you're staring at right now. But it also includes things like the speakers for sound or even a printer connected to a computer. This is the voice and the face of your device. Now, this is really important, so let's be super clear. Do not confuse storage with RAM. Remember, RAM is the temporary workbench. Storage is the permanent filing cabinet. This is where your operating system, your apps, all your photos, and your files actually live. When you turn the power off, the workbench gets cleared, but everything in that filing cabinet stays right where you left it. And storage comes in all sorts of shapes and sizes. Older computers had those clunky, spinning hard disk drives, but most modern devices use much faster solid-state drives, or SSDs. And of course, you're familiar with flash memory. That's what's in an SD card or a simple USB stick. Okay, now that we've taken apart the smartphone, here comes the best part. You now have the fundamental building blocks to understand the entire family of digital devices. Because honestly, the core ideas are exactly the same. Just take a look here. From a gigantic mainframe computer all the way down to your smartphone, they all have a CPU, they all have memory, they all have storage, and they all have software. The only real difference is how they balance those things. A desktop PC gives up portability to get insane performance. A smartphone does the exact opposite. Every device is just a different recipe using the same core ingredients, tweaked for a specific job. And this is exactly why knowing all this stuff actually matters. It's not just about learning some tech jargon. It's about being empowered to make smart choices. When you understand these components, you can choose the right tool for what you actually need to do instead of just buying whatever's newest. So, let's put this new knowledge to the test. You've got the building blocks now. If you had to advise a competitive gamer on what to buy versus a professional film editor, what would you tell them to focus on? A super fast CPU? Tons of RAM? Massive storage? See, the answer isn't the same for both. And the fact that you can now actually think through that choice, well, that shows you now understand what truly makes these devices smart.